Let's say we have 7 marbles which we want to keep safely in a box such that each box has a capacity of keeping exactly 4 marbles. The question is, how many do of these boxes do we need in order to safely keep all of our marbles over here? Our marbles are the items that we have, and the box is our container in which we want to keep our items. Well, this is not a very difficult question, is it? Because the obvious answer is we need exactly 2 of these boxes to keep all of the marbles that we have, right? In the first box, we will keep the 1, 2, 3, and 4 marbles. So 1, 2, 3, and 4. And in the last box, we will keep the remaining 5, 6, and 7 marble. So 5, 6, and 7. Yes, one of the spaces in the second box will go empty, but that's fine. Our condition was we have to place each marble inside the box. It is not necessary that each box should be completely filled up, especially when we don't simply have enough number of marbles. So, what we answered over here is a more general category of problems called the ceiling division problem. A ceiling division problem always contains some sort of container. This container in our example was a box, but it could also be, for example, a car. A car could be a container, right? Because it you can use a car to, let's say, seat people. And instead of marbles in the car example, you would have instead of the marbles. So those people basically, or these marbles, represent what we call items. So the main thing is that there are items and we want to keep those items in the container, and we want to know how many such containers do we need. Now in this example, it was quite easy, but your Qudraat exam will have problems with much larger numbers, so you need a more organized and shortcut way of solving such problems. Well, here's how you do that. In order to calculate the number of containers, what you do is simply take the number of items and divide that with the capacity of one container. In the example that we just did, the capacity of one container was 4, right? So let me follow along with that example. The number of items, which was the number of marbles we had, was 7, and the capacity we had was 4. As a result, if you check, the answer we are going to get is going to be 2 point something. Sorry, it's going to be not 2 point something, it's going to be 1.75 something. The exact answer is not important, but it's going to be some decimal number. So this is the first thing you do. You take the number of items, you divide that with the capacity, and you look at your answer. Now, if your answer has a decimal in it, then what you do is basically ignore the decimal. So if we were getting 1.75, we will ignore the decimal, right? So from 1.75, we will just have 1, and then we have to add 1 to it. So the 1 becomes 2, and that becomes our answer. What if there was no decimal that we were getting? Then in that case, that is your answer. So that is going to be the number of containers you're going to need. So the bottom line is that you simply take the number of items, divide that with the capacity. If there's a decimal, ignore the decimal and then add 1. If there is no decimal, then that's your answer. That's it. Let's try out a quick problem based on this. There are 39 students who plan to go on a trip. Each bus has only 19 seats, and so we want to know how many buses are needed in order to take the students onto the trip. Well, again, we remember that we need to know the capacity. The capacity over here of a bus is 19. So that is our capacity. And the total number of items in this case is 39. So that's items. And remember, what we need to do is simply take the number of items and divide that with the capacity. So we take 39 and we divide that with 19. Now, we need to, of course, guess what this is going to be. Well, we don't need the exact uh, division. All we need to know is if it is going to produce a decimal number or not. Well, it is going to produce a decimal number in this case because the answer is going to be something close to 1.9 something. It's fine, you don't need to know the exact calculation. Even I might be wrong over here, but that's the point. The exact number is not important. What we know is that it is going to produce a decimal in this case, right? So when it produces a decimal, what do? We ignore the decimal and then add 1 to it. So we do exactly that. We ignore the decimal, so we get 1, and then we add 1 to it. So we get a 2. So that is going to be our answer in this case.